Okay, guys, so hello once again, and today I'll be talking about the Fishjam Media Server. My name is Przemysław. I'm based in Krakow, Poland, and I'm working at Software Mention. For over 2 years, I have been working in Elixir in multimedia, and for about a year, I have been developing the Fishjam Media Server. Well, actually, if you have used maybe it before or something, then it was called Jellyfish because we very recently changed the name, but it's been out there for around a year, I think. So before I tell you more about Fishjam, let me introduce you to some basics of online video streaming. So probably most of you are familiar with tools for online conferencing, for example, Google Meet, which we are using right now, or Microsoft Teams, or Zoom, or Cisco WebEx. And all those tools use the same technology, which is WebRTC. And WebRTC stands for Web Real-Time Communication. And basically, it's a set of protocols or a standard developed by Google in the early 2010s. And it allows for sending any kind of data through the internet in real time with minimal latency. So think hundreds of milliseconds, and in good scenario, it's around 100 milliseconds. So very good latency for online conferencing. So you barely see any latency when talking with someone. It's very fluent, so it's really nice. Also, WebRTC is designed as a peer-to-peer connection. I'll tell you more about it in a moment. Yeah, and it's supported by most browsers. It's also really important because you can use it in any browser from the JavaScript. Okay, so I'll explain a couple topologies associated with WebRTC. So since WebRTC is peer-to-peer, kind of the first and most basic topology to use is full mesh. So let's say if there are a couple participants in an online meeting, it's okay to use. You don't have any server in between. You just connect to all other participants and send and receive all videos. But as the number grows, for example, to 10 participants and more, network usage and the bandwidth is just too much, right? And you quickly run out of network bandwidth because you receive all streams from all participants and also send your stream to all other participants. So what you can do is use MCU, which is multi-point control unit, and it introduces a server which is in the middle of the setup, and all participants, all browsers just publish their stream to the MCU, and then MCU composes the video. So creates a single video stream from all those videos and publishes this stream to all participants. And from the participant perspective, this is really great because you only send one stream to the server and receive a single stream. So just two streams, the network usage is minimal. But it turns out that it's not really good from the server side. So having this MCU is really CPU intensive, and as the number of participants grows, it's just you cannot support such server. You would require some immense machine, which would cost, I don't know, hundreds of dollars, I guess. So there is another solution, which is called SFU, and it means selective forwarding unit. And well, the name is kind of self-explanatory. So it selectively forwards the tracks it receives. So in this setup, all participants first send their video to the server, and then those video tracks are published to all other participants. The benefit is that you only send a single track and receive all other participant tracks from the server. However, there is some room for optimization, for example, in this setup. So if you have, let's say, 100 participants in an online meeting, but you only display, let's say, 20 on the screen, then you don't need to send all those 80 videos of other participants to this person, only 20 videos, right? So you can save some bandwidth here. Or for example, when someone that doesn't speak at the moment doesn't send any audio, then you probably don't need to send their video as well. And that's what Fishjam essentially is. It's an SFU. However, it's based on membrane RTC engine, which in turn is based on membrane framework. So let me start from the bottom up. So from the membrane framework, it's a multimedia library written in Elixir. It's designed for any kind of multimedia processing or audio or video. And the membrane framework is designed around the concept of pipelines. So there are like elements which are connected to each other and they're like in a chain, So you send some data from one element to the another one, which is in this sequence. And there are three types of elements in membrane, which are sources, filters, and sinks. So the source element is an element which kind of creates data. So it either takes it from network, from somewhere. It can publish it from file, for example, or we can have some fake source which just generates some dummy video or audio. Then we have the filters, and the filters take some data in some buffers and process them in some specific way, right? So we can have, for example, a decoder which takes encoded video and decodes it and returns raw video for some further processing. And then we have sinks, which simply only consume data and do something with it. For example, save it to file or send it somewhere else over the network. So I can share with you some sample pipeline you can create with Membrane. And this pipeline you can see right now consumes 2 videos from the network, and then it composes them together. And this video is then both saved to a file and published further somewhere else through the UDP sync. And this kind of setup could be used, for example, during online conferencing. So we could feed 2 videos of the participants into this pipeline. Then we would mix it, creating a single video with both of the participants, and then encode it and save it to a file. So the file would serve as a recording for later, but at the same time we could forward it somewhere else, right? Maybe publish it to YouTube to broadcast it. So the possibilities are quite versatile, I guess. Okay, so now comes Membrane RTC engine, which uses Membrane. And RTC engine is an Elixir library, which is designed around WebRTC. And we have an implementation of WebRTC in Membrane, which is used by the RTC engine. And the engine allows for creating real-time applications, generally oriented around WebRTC, but not only, because we have some other components which can extend the functionality of this application. So one of the most simple examples or usages of RTC engine can be a video room. What you are looking at right now is just a demo that we have in our repo. So it's a very simple video room where you specify the name of the room, your display name, the participant name, and then you can join a room with other participants. And now let me show you some code. Don't get into it too much because it's not really important what we're doing here. I just want to say that this piece of code you are looking at right now is responsible for creating a new room. So for example, when someone wants to join a room, but it doesn't exist yet, so they are the first person to join, we create a new room, which comes down to starting or spawning a new RTC engine process, which happens somewhere at the bottom of this snippet. But first, we need to configure the network and some other stuff, which you have to do for it to work, but it's also a little bit inconvenient. And the same goes for adding a participant. So if the room is already started, this is what you are looking at right now, is responsible for adding a participant into the meeting, right? And the first piece of the snippet is just configuration. And so, as I hope you learned on this example, there's quite some boilerplate associated with RTC engine, because every time you want to create an application using RTC engine, you have to basically copy and paste this code I've just shown you. And also in some more advanced use cases, it can be a little bit complicated. So it would be hard, I think, to just create a simple POC with RTC engine without diving too much into the details of how it works and learning some tutorials. And Elixir here is with question mark, but I'm pretty sure not many people use Elixir. That's maybe a pity because I love Elixir and think more people should learn it and use it, but it is what it is. So we don't want to use Elixir like every time we want to some multimedia solution, right? So that's where Fishjam comes into play. And this is an SFU. It's based on RTC engine, but essentially Fishjam is a Phoenix application which delivers some REST API for easy management of the rooms, for creating the rooms, other participants, and other stuff as well, so other features. So let me introduce you to the main concepts of Fishjam. So within a Fishjam instance, within the Fishjam server, you have rooms, and rooms are like completely isolated from each other, and everything that takes place within a single room. And into the room, you can add peers and components. And there is currently one type of peer in Fishjam, and it's called WebRTC peer. And it's basically a process associated with some kind of client, right? In this moment, it's a browser. So some kind of participant joins in and connects to the Fishjam through their browser using WebRTC. And components are more a server-side thing, so they are not also associated with any client, and they can still publish and consume some tracks. So for example, components, we have recording component in Fishjam, which essentially connects to all other peers and components inside the room and subscribes to their tracks and just saves them to file for later processing to create a recording of the meeting. Or we can have component which publishes some kind of media stream. For example, an RTSP stream from an IP camera. Let me show you how the WebRTC peer works. So how would you go about adding a peer to the Fishjam room? So let's say you have some pretty common setup with some front end, some backend, and the Fishjam could be either on the same machine as the backend or someone else, let's say maybe even in the cloud. So what you do is, in order to add a participant to the meeting, you first create a request to the backend, which then forwards it to the Fishjam instance. And if everything goes well, you create the peer and receive the associated peer token, which is then used to authenticate the client to Fishjam. And so this peer is returned to the front end, and this all happens using the REST API. And we use this token to open a signaling channel from the front end to Fishjam. And this channel is a WebSocket. And there is also another channel used for data. So the first channel, the WebSocket, is for signaling, for sending some messages. For example, that a new track was added, that someone published a new video stream. And the second channel is just UDP media. So either you receive a video stream from someone or send your video stream to other participants. So to Fishjam, and then it's forwarded to other participants. And okay, so now let me show you how the Fishjam dashboard works. So what it is we have this tool. Yeah, it's called Fishjam dashboard, and it's used mainly during development. So if you want to quickly check what's going on our instance, Jellyfish, the old name, right? If you want to check out what's going on the Fishjam instance, we use it. And yeah, here's a short video showing how it's used. So first we add the server provides the authentication token. It's different from the peer token that I talked before, because we have some kind of master token used for connecting backend to the Fishjam. And this token is used for any kind of room management, adding rooms, removing them, adding participants, and this kind of things. So it's a server side thing. Yeah, we provide the address of the server. Yeah, and as you can see here, there's not much going on. Especially in the bottom, there should be some rooms listed if they were present, but there are none at the moment. But we can add a room. So what dashboard does, it has integrated both the client and the server SDKs. So we are able to create a room as we would do from the backend. But we are also able to connect from client side. So we are able to connect to the Fishjam server and publish some video or any kind of maybe audio track, right? And so yeah, what we do is just create some sample video stream and publish it. And in order to see and to verify that the Fishjam is receiving the stream, we add another peer. And once we connect this second peer, you can see that it receives a remote track from the Fishjam. And now we can do it another way around. So the second participant can add video track, publish it, and you can see that the first participant is receiving it. Okay, so now I'll show you a quick demo of using the Elixir server SDK. And here I have a short snippet of code. What it does is first we create a client, which is basically an HTTP client, and we provide the server address and token to authenticate to the Fishjam server. Then we create the room. In return, we receive the room ID, which we then use to add a peer to this room. So some kind of UID is returned, and we just provide it and specify that we want to create a WebRTC peer. And once that happens, we just print out the peer token to the screen. And we are going to use it to authenticate the client to the Fishjam and then publish some multimedia tracks. Okay, so here's a demo. I wanted first to do it actually live, but I decided to be safe, so it's just recording of me doing it a little bit earlier. And so as you can see, we use the dashboard to visualize what's going on and also to publish some media tracks later. So as you can see, there's nothing going on in the Fishjam server. Now I go to the terminal. In the first tab, I've got the Fishjam running locally. And now I will execute the snippet. And as you can see, we have received the peer token. And now I'm going to use it to authenticate the peer. So as you can see in the dashboard, there is a new room created, and there is also a peer, which we have also added. So I just provided the token that we have received from the Fishjam. And now we can successfully connect to the Fishjam server. And similarly to what you have seen before, we just add some video stream. It's my camera in this case. And I just add another participant to verify that the stream is actually working. Okay. So you have already seen in action two SDKs. So the server SDK written in Elixir, and also the TypeScript client, which is used by the dashboard. We've got a couple of others, namely the Python server SDK and some other client SDKs. And one more thing that I want to mention that we have introduced in Fishjam is the load balancing. So what you can do with Fishjam is create more than one instance of the server and connect them. We are using libcluster to do it. And once the Fishjams are connected in a cluster, the process of spawning a room, it's a little bit more complicated. So we want to find the server on which there is the lowest resource usage and only create the room on this very server. So first we ask all other servers in the cluster or other nodes I should say, find the one that has the most resources left, and on this server or on this node, we create the room. And in response to the backend's request to spawn a room, we return also the information on which node the room has been created. So any further modifications to the room, or for example, adding peers, must be directly requested from the nodes on which the room is running. Okay, so that's it from me today. Let me just share with you some other related projects which we are working on right now. The first one is Elixir WebRTC. So as I have said, we've got an implementation of WebRTC in Elixir. However, it's in membrane. And what we are doing right now is making an implementation of WebRTC outside of membrane framework. There is also, the membrane framework project, which I highly recommend, especially, you are here at this meetup, so I assume you already know Elixir. So if you want to learn some multimedia, for example, then I recommend you check it out. And there is also a Fishjam Cloud, which is kind of a next step for our project. So we are working on it right now, and probably soon we'll release some beta version of the cloud. And one last thing that I want to share is the RTSC On. It's a multimedia conference that we are having in Krakow in September. And it's going to be a second edition, and there are going to be a lot of workshops, and a couple of them are aimed at people who are beginning their journey with multimedia. So if you would like to learn more, then I recommend it as well. And that's it all from me today. Go check out our organization on GitHub, and thank you for listening.
Awesome. Looks like we have a question. Bonnie?
So, do you have any plans to build a client in Elixir?
So, well, not really. I don't think there is like an application in which we would need an Elixir client, I think. So there are no such plans, I think, in the near future.
I was just thinking, if somebody didn't want to use an app, if you just wanted to do everything, just browser connecting to the server.
So you mean without having the backend in Elixir, for example, or any kind of backend, right?
Yeah.
So in this case, you can, as we do in the dashboard. So in the dashboard, we have both the client and server SDKs, and the server SDK is actually in TypeScript as well. So we provide the open API specification. For some languages, you can just out of the box generate the client for this language. And that's what we do for TypeScript. So it's possible to have some kind of, application website where you have only the front end with integrated server SDK. So you have only the Fishjam running somewhere and the front end, if that's what you are asking. I don't know. Sorry.
Yeah.
Okay, great.
How is the latency? Yeah, I know it depends on how many people are using it and a lot of what kind of web connection you have. Is it possible for people to say play jazz on this?
So we ran some multi-region tests. So there was a server which was located in the US and some clients which were in Europe, for example, or in Asia. And generally, the round trip time was between 100 and 200 milliseconds. However, that was assuming that you had a good network connection in this geographical location. So I'm not that into music, so I don't know if, let's say, 200 milliseconds is okay, or if it's just too much of latency for playing music.
Yeah, I would say that's too much for music, but that's good to know. Thank you.
Yeah.
What's the plan to, say, monetize this? Because obviously, you guys need to keep working on this and you have bills to pay, etc. Is there a plan to have a pro version? Or I know you guys are doing consulting work. So is it to use the consulting work just to keep working on this? What's kind of like the way that this can become more self-sustained?
Yeah, we do some consulting, definitely, but I think the main idea for monetization and selling it is the cloud. Yeah, definitely. So it's something that we are working hard on right now. And we are going to release some beta, which hopefully will turn out, with success. And we also hope to find some people who are interested in using it. Yeah, so I think that's the main selling point here.
Do you have a roadmap for upcoming features?
Well, not really. So we usually just plan one, release ahead, and the releases tend to be around 3 to 4 weeks. And so what we are working on currently is the distribution. So I explained how the distribution works currently, but it's a little bit limited because once you create a room somewhere on other Fishjam instance, then you need to communicate with this very instance, which is kind of problematic from the, let's say, backend point of view, because we would like to be able to communicate and send the requests to any Fishjam in the cluster and just pawn the responsibility of finding the room and knowing where the rooms are on which node in the cluster on the Fishjam itself, right? So that's what we're working on right now. So to make it transparent from the server side, right?
What does Elixir bring you that, say, another programming language doesn't bring you? Because, I mean, obviously most of us know, but could this actually use another programming language? Or is it just like you guys like Elixir, so you use it? Or does Elixir have some features that make it most suitable to use for this kind of project?
Yeah, I think the main idea is, first, we like Elixir, definitely. The other thing is that we are kind of used to it like historically now, because we had this membrane framework that we've been working on, and then new projects came to be, and we just decided to continue on using Elixir for them. Well, there are some things, for example, this clustering that I mentioned, but personally, I don't think that there are any like deal breakers. So things that we have in Elixir, but wouldn't be able to do in some other language.
I'm interested in trying it. What is your timeline for the cloud?
I don't know exactly all the details, but I'm pretty sure that the beta version is going to be released in a couple weeks, I think, and maybe a month, I think, something like this, but I'm not really sure about the details. So, but you can, I think, try to run it yourself on your machine. We have some Docker images, which should be relatively simple to set up. Assuming you are running on Mac or on Linux, then you should be good to go.
Yeah, we're thinking about trying it with my friends, just to actually do a remote call, to use it like Zoom or like,
Okay, I see.
just for a meeting.
Yeah, so we can stay in touch when the beta version is released. Let you know. So if you're interested, you can, I think, mail us or maybe at our Discord. So we have Discord server for the membrane framework and for the Fishjam specifically as well. Maybe I can direct you there, I think.
Got it. Thank you.
Thank you.
Any other questions? Otherwise, I think it was a great presentation. I remember seeing this. So you guys just did a renaming from
Jellyfish.
Jellyfish to Fishjam. Why all the C related?
I don't know. It's kind of used to this. I think it's all started with membrane, because membrane, I don't know how the name came to be, but there is this jellyfish in the logo of the membrane framework, right? And when we started Jellyfish, we just thought, well, it's funny to name it Jellyfish. But then it turned out that, first of all, we don't have a good logo because we can't put jellyfish there because there's membrane, which has already jellyfish in the logo, right? Also, there are some other products which have similar names, especially the Jellyfin project. So it's like hard to be ranked somewhere, in the Google. You know what? I'm not really sure because there are a lot of ideas. So I think we just stick to this marine motifs, I guess.
All right, we was just curious what's with the naming. I didn't even think about the membrane logo. To me, I think about membrane. I think about like the cell of like an organism rather than something to do with jellyfish. But okay.
Oh yeah, right. Yeah, it's a hexagon. I didn't think of it like this, but it's cool also. Yeah, we had a couple ideas. We also were wondering if we should change the name to Gemfish. Something about this jellyfish is still there, right?
So thank you again for your presentation. It was really great. It's cool to see, it's being worked on again. Like I said, I'd seen it in Kobane, Berlin. Some of your colleagues were there. They presented it. It was pretty interesting.
Yeah, exactly.
So I was happy to have you guys back.
Yeah, thank you very much
again,
for reaching out, by the way, and I really appreciate being here once again. So yeah, thank you guys. And yeah, hopefully see you somewhere as well.
Definitely.